Okay, now welcome back. Today I'm going to start with matrix. It is in the syllabus of Standard 12 Mathematics. Now, what is matrix? In books language, you can say a matrix is an ordered rectangular array of number or function. Order rectangular array. Now, what is the meaning of this? Now, array consists of rows and columns. Now, let us start with a practical example. Students are sitting suppose in a classroom, and there are 4 horizontal lines. These horizontal lines are called arrows, and the vertical lines are called the columns. Now, suppose there are 3 rows are there, like this way, horizontal lines 3, and there are 5 columns. So total 3 into 5, 15 students are sitting in this design. Okay, and this is actually a 3 by 5 matrix. Okay. Now, let us start with an example. Suppose A is a matrix and it is like this way: 2, 3, 4, 5, 6, 7, 8, 9, 6. Now, here you see this is row 1, this is row 2, this is row 3. This is column 1, this is column 2, this is column 3. So, order is here 3 into 3. If I take another matrix B, and let us take as 2, 1, 5, 3, 6, 7. Here there are 2 rows and 1, 2 and 3 columns. So we'll write 2 rows into 3 columns. So this is the order. This is the order of the matrix. Now in general I can write a matrix K is equal to Aij M into N. That means M rows and N columns. These are the elements. Now this can be written like this way. So K I can write A11, A12, dot 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 A1N. That means the row number 1, column number 1, row number 1, column number 2. Like this, row number 1, column number 3, and dot 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 row number 1, column number N. Now next you start row number 2, column number 1, A22, A23, and like this way A2N, and it will go up to, we start with AM1, AM2, AM3 and dot 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 AMN. So this is M cross N or M by N. This is the order here. M rows and N columns are there. So this is the definition of the matrices, and this is the order. Now come to the types of matrix. Now some matrix, suppose a square matrix. Now, what is a square matrix? What is a square matrix? Now, when the M is equal to N, that means the order is same. Now, suppose here I am writing 1, 2, 3, 4, 5, 6, 7, 8, 9. So, the order is 3 by 3. So, this is a square matrix of 3 by 3 order. Now, in this square matrix, if the diagonal elements, these are called the diagonal. This is the diagonal. This is the principal diagonal. And this diagonal called auxiliary diagonal. But we will work with the principal diagonal, main diagonal. Okay. Now when the diagonal elements are, suppose, these are fixed. So then what will happen? So first of all, we will write the diagonals of this matrix. Suppose A is what? 1, 5, 9. They are the diagonals. Okay. Now, what is diagonal matrix? Diagonal matrix. Now, the square matrix. So it's a square matrix. That means the order are same. The square matrix where the non-diagonal elements are 0. Now suppose here 2, 3, 4 is a diagonal element and the rest these are 0. Then this is the diagonal matrix and we can write it as like this: diagonal DIAG 2, 3, 4, like this we can write this. Suppose the name is B, so I can write B is equal to this. So this is a diagonal matrix where this is a square matrix, order is of course 3 by 3, and the non-diagonal elements all are 0. Now if I put some restriction here, if I put all these are same, a constant. Suppose if I write a matrix C where these are all are 2, 2 and 2. If I take this one example, so this is a diagonal matrix whose diagonals are all same, constant, diagonal constant. So here what you see, diagonals are constant. Then it is called, then this diagonal matrix is called a scalar matrix, SCALAR, scalar matrix. That becomes a scalar matrix where the diagonal elements are constant, fixed, they are equal. And when in the scalar matrix, when the diagonal elements are same and they are 1, 1 and 1 only, that means it will look like this way, then it is called the identity matrix. This is I3, 3 by 3. So I3 is called the identity or unit matrix. Identity matrix. So these are the basic things about the different matrix. And apart of this, there is a null matrix. Null means what? Null matrix or zero matrix. What is zero matrix? Now suppose O is a zero matrix, and that will be suppose like this way. 3 by 3, you can say, is zero matrix, 3 by 3 order. Or I can say another matrix, a 2 by 2 order. So these are all the null matrix. Okay. Just one check here. A scalar matrix we have missed here, so put a 0 here. So these are the position. Okay. So what you have seen that this AII position actually. This is called AII position. Same. This is the 1 1, 2 2, 3 3 position. These are the diagonal position. And these are the I naught is equal to j. These are the non-diagonal position. Okay. Now, just a problem related to this discussion. This is a problem from NCERT and is a board model question also. Now you see the question. Construct a 3 by 4 matrix whose elements are given by Aij is equal to half into mod of minus 3i plus j. Now, how to do this? Now, we know a 3 by 4 matrix we can write A11, A12, A13, 14, 2 1 2 2 2 3 2 4 3 1 3 2 3 3 3 4. That means 3 rows and there are 4 columns. Okay. Now Aij is given, this is the half into mod of minus 3i plus j. Now we'll put I is equal to 1, 2 and 3 rows and columns are j 1, 2, 3 and 4. So if I put A11, so what is 1 1? I is equal to 1, j is equal to 1. If we put this, we'll get 3 into 1. Minus 3 into 1 plus 1 mod, then 1 by 2, it is coming 1. Similarly, A12 is coming, putting I is equal to 1 and j is equal to 2, we are getting half. A1, J3, we are getting 0. And similarly, by proceeding, we are getting A11, A12, A13, A14, A21, each and every one we are getting. And finally, we get A is equal to 1, half this, 5 by 2, 2, 3 by 2, 1, 4, 7 by 2, 3 and 5 by 2. So this is my answer. This is a board model question and usually it is come up 2 marks. Now next question number 2, just I am discussing. On CBC 2013 I have picked up this question. Find x, y, z, w if this is a given. This is a position. A11 position, A12 position, 21 position, 22 position. And this minus 1, 5, 0, 13 is given. Now we know that in equal matrices where both 2 by 2, so equal matrix, it is also 2 by 2, this is also 2 by 2. So they are equal matrices. Now the corresponding elements will be equal. So in place of x minus y, I can put minus 1. In place of 2x plus z, I can put 5. In place of 2x minus y, I can put 0. And in place of 3z plus w, we can 13. So we can write it, and by solving, we are getting x1, y2, z3, and w as a 4. Now one very interesting NCERT problem that usually comes in the board also. The number of all, this is an MCQ question. The number of all possible matrices of order 3 by 3 with each entry as 0 and 1 is what? 27, 18, 81 or 512. Now the answer is 512. Why? Now a matrix of order 3 by 3, that 3 by 3 means it has in how many elements? 9 elements. Because 3 by 3 means it is like this way. This, 3 by 3. So total 1, 2, 3, 4, 5, 6, 7, 9 elements are there. And according to question, each element is either 0 and 1. So 9 places, this 1, 2, 3, 4, 5, 6, 7, 8, 9, these 9 places, each place can be filled by either 0 and 1. So total 9 places can be filled up in the 2 to the power 9 ways. That means 2 into 2 into 2 into 9 times. So it is coming 2 to the power 9, that is 512. So D is the correct answer. Now we'll see the operation of on matrices. Now a matrix A, suppose Aij. Now if you multiply by a constant K, then it will be Kaij. That means if you multiply a number, suppose matrix A is 1, 2, 3, this is the matrix. If you multiply by 2, so what is 2A? Each element will be multiplied by 2. So that is the main thing. Now, when you see the matrix addition or adding or add or subtracting, we'll see that the matrix addition follows the commutative and associative law. But the order should be same. Then they are compatible for that. Now, what is additive identity? Now, A plus this null is equal to A back. So this is the zero matrix or null matrix is the additive identity. Now what is additive inverse? Now A plus minus A is equal to this null. So minus A is the negative of A. This is. Now what is matrix multiplication? Now if A is a matrix of order m by n and another matrix B is n by p, then this is the product C is A, the product C is the product of A and B, and this is written as Cij m by p. That means here this got cancelled. This is rows and columns, and this is the rows and columns. You see the column of the matrix A must be row of the matrix B. The column, I repeat, the column of the matrix A must be the number of row of matrix B. Then only you can multiply. Then this to get cancelled, and finally we get m by p. What? AB. So C is equal to AB, and the order is m by p. This by this, m by p. So what I have told, number of columns of A is equal to number of rows of B. Then only A by B, A cross B is possible. Now this is not commutative. That means A cross B, not necessary, it is equal to B cross A. It is only possible when A and B have the same order. Okay. Now one more interesting thing you see. We know for real number A and B, we know A into B, the product of AB is 0. Then either A is 0 or B is 0. But this result is not true for the two matrices A and B. Now suppose A is a matrix of this of 2 by 2 order, B is a matrix of again this 2 by 2 order again matrix. Then if I take C is equal to A into B, then how it is multiplying? These rows and these columns. Now this row 0 is multiplied by 3, minus 1 will be multiplied by 0. So 0 into 3 plus minus 1 into 0. This into this plus this into this. This row, first row with first column. You see how I am multiplying. The first row with first column. First row with first column. That means 0 is multiplied by 3, minus 1 multiplied by 0. So it is coming this one. Then first row, second column. The first row 0 is multiplied by 5, minus 1 is multiplied by 0. So we are getting first row, second column. Similarly, second row, first column. So 0 into 3 plus 2 into 0. We are getting this one. And finally, we are getting the second row and second column, 0 into 5 plus 2 into 0. So this one. And we are getting this. So what we are getting in this example, the C is equal to 0. So null matrix. That means A into B is null, but you see that either neither A is null or nor B is null. Okay. So this is the result. Now, matrix multiplication follows the associativity and distributive law also. So, and what is the multiplication identity? We know AI is equal to IA is equal to A only, where A is a square matrix and I is the identity matrix. I have already told what is the identity matrix in the previously. Okay. Now, before starting with the transpose of the matrix, I want to tell all my students that you must have this, my notes, that in the written form in front of you, and I have already, it is given in your portal of our school. Okay, now what is the transpose of matrix? Now if A is a matrix of M cross N, means M rows and N columns, then when I write A dash or A transpose, I can write this AT also, A transpose, or this, then interchanging the rows on column, that will be JI N cross M. That means I comma jth element of A is equal to J comma ith element of A dash. Now, when you transpose and again you retranspose, then you go back to A again. So A transpose, whole transpose, you get A. Now suppose A is equal to 1, 2, 3, 4, 5, 6. So it is 2 into 3, 2 by 3, 2 order, 2 by 3 orders, means 2 rows and 3 columns. The elements are 1, 2, 3, 4, 5, 6. Then A transpose will be this row will become the first row will become the first column. So 1, 2, 3 become the 1, 2, 3. And second row 4, 5, 6 is becoming second column. Now again you retranspose here. If you see A transpose, again you transpose this, then again it will back to this row will become the column. So 1, 2, 3 and this is 4, 5, 6, which is nothing but again A. So this satisfies this result. Now we'll see that if we K is a constant number, you multiply by the matrix and transpose, then K will come out, K A dash. Then A plus B transpose, then A transpose plus B transpose. And A, B product transpose is B transpose, A transpose. Now a square matrix A is symmetric. Now we have discussed about symmetric and skew symmetric. Now what is symmetric? The square matrix A is symmetric if A transpose is equal to A. That means after transposing we are getting the same one. That means AJI is equal to AIJ. And what is skew symmetric? If A transpose is equal to minus A, that means AJI is equal to minus AIJ. A transpose is equal to minus A, then it is called skew symmetric. That means AJI is equal to minus AIJ. Now that means if I write AII is equal to minus AI, this will go this side. 2AI 0, so AI is equal to 0. So we can reach to a result that every diagonal element of a skew symmetric matrix is always 0. Okay. Now let us see one very important and very interesting result, and it's important questions also, that prove that every square matrix is an expressible as a sum of the symmetric and a skew symmetric matrix. Now how will start, you see. If A is a square matrix, then we can write A is equal to half A plus A prime or A dash plus half A minus A dash. Now let this A plus A dash as a P and half A minus A dash as a Q. P and it is Q. Now where P is this and Q is this. Now what is P transpose? P transpose means this is half A plus A transpose whole transpose. Now half will come constant out. Now this A plus A whole transpose, then A transpose plus A transpose that we have seen here in the previous one. Here we've got this A plus beta, A transpose and B transpose. So this property holds here. So A transpose plus A transpose means is coming A again. So it is nothing but again P. So P transpose is equal to P. So P is symmetric matrix. Now what is Q? Q is we have taken, so this here Q, where is Q? Yes, Q we have taken half A minus A transpose. Now I am finding Q transpose. So this over half will come out. Now A transpose minus transpose, so it is coming A back. So this is my minus half taking common, so A minus A dash is minus Q. So Q dash is minus Q, so Q is skew symmetric. So I can write A is equal to P plus Q, symmetric matrix plus a skew symmetric matrix. Okay. Now the very important question in the board model, CBSE to the it usually comes of 4 marks. It usually comes of 4 marks. Now express a matrix A as a sum of a symmetric and a skew symmetric matrix. A is given 3 minus 1 0 2 0 3 plus 1 minus 1 and 2. Now let us start with take a matrix P as a half A plus A prime. Now A I have written, A transpose I have written. Then half you take common. This will add to this. This will add to this. This will add to this. So 3 plus 3 6 minus 2 plus minus 1 plus 2 is coming 1 and 0 plus 1 is coming 1. 2 plus minus 1 is coming 1, 0 plus 0 0, 3 plus minus 1 coming 2 and 1 plus 0 is 1, minus 1 plus 3 is equal to 2 and 2 plus 2 is equal to 4. So we are getting this. Now, so P is, if you multiply by half, you will getting each element will be multiplied. We have seen there in my previous property. So half into 6 is 3, half into 1 is half, half into 1 is half, half into 1 like this we are getting this one. Now what is P transpose? Now all this row become columns. So this we are getting, this row is coming this side, this coming this way, second row, second column, third row become third column. We are getting nothing but again P. So P is a symmetric. Now what you observe that a symmetric matrix, that this part A, Ij and Ji, these two are equal. Similarly A 1 3 and 3 1 are equal, and this is 3 2, 2 row 3 column and 3 row 2 column, these two are equal. So if these two equal, these two equal and these two equal, we can say easily it is a symmetric matrix. Any matrix we can say symmetric by seeing only this part. Second, the first row second column is equal to second row first column. That means A12 is equal to A21, A13 is equal to A31, and A23 is equal to A32. This two and this two and this two are equal, then we can say it is a symmetric. Now, Just testing of Q symmetric. Let Q is equal to half A minus A prime, A dash or A transpose, whatever you say. Now half A minus A transpose. So A is this, so transpose is this. Now we are subtracting. Now 3 minus 3, minus 1, minus 2, and corresponding we are writing, we are getting this one. Half is multiplied, we are getting this. Now Q transpose, again we are doing this rows to column, we are getting, whatever we are getting, that is minus Q. So Q is skew symmetric. So P plus Q, I can write, this is my P and this is my Q. And if you add, then 3 plus 0 is 3, half plus minus 3 by 2 is minus 1, half plus minus 1 is 0, and half plus 3 by 2 is 2, and like this way we are getting this, which is nothing but A only. So we can write P plus Q is equal to A, and this leads to our this proof. Now this is the last questions of today's this video clip. This is very interesting questions on matrix multiplication. As very important for the board exam. You see, it is 2004, 5 and 6, and it is NCERT question also. Now what is the question? Now suppose A is a matrix. Here the functions given, cos theta, sin theta, minus sin theta. In my difference I have told this is an array, rectangular array of number or function. So here A is a matrix, order is 2 cross 2, 2 row 2 column, cos theta, sin theta, minus sin theta and cos theta. You have to prove a to the power n is equal to cos n theta, sin n theta, minus sin n theta and cos n theta. You have to prove this. Now we shall prove this result by using our one principle that we have learned in class 11, that is PMI, principle of mathematical induction. Now suppose n is equal to 1, that means a to the power 1, n is 1, a to the power 1 will be 1. Now put 1 here, so cos 1 theta, sin 1 theta, minus sin 1 theta, so that is cos theta, sin theta, is minus sin theta and cos theta, which is nothing but is equal to A again. So a to the power 1 is equal to A, so this result is true for n is equal to 1. Now let the result is true for n is equal to k. As we proceed, you can remember class 11, as we proceed in PMI. Now the result is true for n is equal to 1. Now let the result is true for n is equal to k. For then a to the power k will be what? Now cos n, in place of n you put k, so cos k theta, sin k theta, minus sin k theta and cos k theta, that we have written here. Now we'll prove this is true for k plus 1 also. Now a to the power k plus 1 is what? Now a to the power 1 into a to the power k. So a to the power 1 means this is only, and k to the power k just I have got like this way. Now matrix multiplication, rows into columns. We have learned rows into the first row, first column, first row, second, like this way. So first row, first column, the cos theta into cos k theta plus sin theta into minus sin k theta. So this is coming. Now first row into second column. So cos theta into sin k theta plus sin theta into cos k theta, and that is coming in this position. First row, second column position. Then second row multiplied by the first column. So minus sin theta into cos k theta plus cos theta into minus sin k theta, and we write it here in this position. Second row, first column, and finally second row, second column. So sin minus sin theta into sin k theta plus cos theta into cos k theta, iterating here. Now this is the formula in class 11, cos of a plus b, cos a cos b minus sin a sin b. This is coming cos theta plus k theta. It is sin a cos b, cos a sin b, sin of a plus b formula, class 11, sin theta sin k plus theta. Similarly this is, and this is again cos. Now what you have got? Sin a k plus 1 is equal to minus the cos of this one, sin of this one, sin of this one, this. So what you have seen that it is in place of n, we have written k plus 1. So the result is true for n is equal to k plus 1. So by PMI, we can prove that a to the power n is equal to this. This is a very important question. And that's the end of this video. Hope it is useful for you. And if any queries, it will be discussed later on.